Thanks for watching this screencast. The objective of this screencast is learners will be able to determine the slope of a linear function given a pair of points on the line. Okay, here is the same definition of slope that we've been working with for this whole learning target. For a linear function, the slope, we use m, is the change in y over change in x. You know, this is the approach we used when we were looking at a table, mostly. When we were looking at the actual graph of the function itself, we thought about rise over run. So this works well with a graph. But our goal today is to use the slope formula given 2 points. So this is the approach that we tend to use given 2 different points. And the x1 and x2, the subscripts here, are not like exponents or anything. You know, you don't need to multiply x by 2 or divide x by 2 or anything. They're just subscripts to denote the different x's. So on top, you're going to do the difference of the 2 y's. On bottom, you'll do the difference of the 2 x's. So there are actually a bunch of different ways you can organize the 2 points problem, and we're going to show you that on the next slide. Alright, in the next couple of minutes, we're going to work the same problem 3 different ways. And your job, as you're watching this, is to decide which way makes the most sense to you. So the problem is determine the slope of the linear function that contains the points, and the points are right here. -3, 4, and 1, 2. Alright, so method 1 would be to make a graph of the line that we're talking about. So maybe I'll take the ordered pair -3, 4 and plot that point on a graph. Start at the origin, go left 3, and then up 4 and plot that point. Maybe I'll then also take the point 1, 2, start at the origin, go right 1 and up 2. And, you know, the line that contains those 2 points is the line right through here. Something like that. So once I've got the 2 points on the line, this is the problem from 13.2. I can take those 2 points as my points and calculate rise over run. So I could say starting at the leftmost point, I could go down 2. And then from that point, I could go right 4. And I could say, hey, well, the slope is just -2 divided by +4. And then to get the actual slope, I could simplify this. A negative divided by a positive makes the slope itself negative. And 2/4, you know, I can divide both of those by 2. I can reduce that fraction and get something like 1/2, 1/2. Our slope is -1/2 here. Method 2 would be to actually use the slope formula. Let me recopy that here. This is on the previous slide. The slope is the difference of the y values over the difference of the x values. So here you want to use the subscripts and maybe go back and label the 2 points. You know, the 2x values here are going to be like x1 and x2. Make sure you use the first value in each ordered pair. The 2 y values are the second number. So to calculate the slope using the slope formula, I just need to replace each of these values here with the values that I've assigned them. So what's y sub 2? It's 2. Minus, now I need y sub 1. Y sub 1 is 4. And I need that all over. Now I need x sub 2 minus x sub 1. So x sub 2 is 1. And x sub 1 is a negative 3, and I need to make sure I put that negative 3 in parentheses because I need that negative sign to apply to it. So once I've got the values in place, now all I need to do is simplify the right-hand side. 2 minus 4 is negative 2. 1 minus 3 is the same as 1 plus a positive 3, which makes a positive 4. And I've got the same value I had here, which reduces to negative 1/2. An advantage of method 2 over method 1 is you don't need to draw the line first. But I think a disadvantage might be that it could be really tricky to get all the signs the way they need to be. Okay, here's method 3. And I'll be honest with you, this is actually the method that I have lately taken a liking to very much. And I also love the fact that this is actually something I learned from my students. I've got students who really like that table problem, where you find the slope from a table, so much that they decided every time they need to find a slope given 2 points, they decide to write those 2 points in a short little table. So they said, I need to find the slope of these 2 points. Let me just write a little 2-column table. Negative 3, 4 looks like this, and 1, 2 looks like this. And now it's like the problem where we said, let me find delta x. You know, what would I add to negative 3 to get 1? It would be a plus 4. And what would I do to get from 4 to 2? I would do minus 2. And then I would say, well, hey, slope is just change in y over change in x, or it's just negative 2 over positive 4. And I go, of course, that reduces to negative 1/2. Isn't that a simple way to find the slope? And notice that in all 3 methods, I'm going to go back a slide for a second. In all 3 methods, we found the exact same answer for the slope, negative 1/2. I'm going to encourage you, even though it works, to try to avoid method 1 given 2 points, simply because I think it's time consuming. I think it would be difficult to maybe make the graph accurately always, and it just takes up a lot of space, you know. You need to have the graph already made. Method 2 is good. Method 2 works well. I'm really going to push you to try and do it with method 3 if you can. Okay, let's work a few together. I'll work a couple and then I'll pause the video and ask you to try to. Let's define the slope of the line that contains these 2 points. And I'm really going to model this idea of let's make the table. So let's make an xy table for negative 4, 2. Let's use 1, 5. And let's find delta y and delta x. What would I do to get from negative 4 to 1? I would add 5. Negative 4 plus 5 is 1. What would I do to get from 2 to 5? I would add 3. So my slope is positive 3 over positive 5. The 2 positives will divide to make a positive answer for the slope. And 3/5 does not reduce. So the slope is just 3/5. Let's try this example. Let's find the slope of the line that contains 5, 2 and negative 3, 8. I'll make my table. I need 5, 2. I need negative 3, 8. What can I do to get from 5 to negative 3? Well, negative 3 is less than 5, so I need to subtract. How far do I need to subtract? I need to subtract 8. 5 minus 8 is negative 3. What would I do to get from 2 to 8? Well, I need to add 6. So my slope is positive 6 over negative 8. Now I want to simplify that, and this will simplify Because a positive divided by a negative makes the actual fraction negative. And 6/8 can be written by dividing the numerator and denominator by 2. I can write that as 3/4. So my slope is negative 3/4. Okay, you know what time it is. Pause the video. Try these two problems. See if you can find the slope between each set of points. And when you think you've got it, hit play to get some feedback. Let's find the slope between these 2 points, -8, 3, and 6, -1. So -8, 3 belongs in one row. 6, -1 belongs in the other. How do I get from -8 to 6? I need to add 14. That's a lot. -8 plus 14 is 6. How do I get from 3 to -1? Well, I need to subtract 4. 3 minus 4 is -1. So my slope is -4 divided by a positive 14. Is the sign of the answer going to be positive or negative? Yeah, it's negative, isn't it? Because the signs are different. Can I reduce this fraction? 2 divides into both 4 and 14. Is anything bigger than 2? 4 doesn't go into 14. So the answer is no. I just need to divide these each by 2. Let's write that as -2/7. Here's my slope. Let's look at this one. We want the slope of the line that contains -2, 10. Let me write that. -2, 10. And -5, 19. So let me find my delta x. What can I do to -2 to get to -5? You know, this is actually less than -2, so I need to subtract 3. -2 minus 3 is -5. What could I do to get from 10 to 19? I could add 9. So here my slope is positive 9 divided by -3. I'm going to get a negative answer because the signs are different. And actually 9 divided by 3 is just 3. So my slope is -3. Two more. Let's find the slope of the line that contains 11, 4 and -2, 4. Oh, that's interesting. What could I do to get from 11 to -2? I need to subtract 13. 11 minus 13 is -2. What can I do to get from 4 to 4? I can add 0, that's right. So my slope is 0, positive 0 is 0, isn't it? Divided by -13. What's 0 divided by any non-zero number? Yeah, it's just 0. This line has a slope of 0. And for Mr. Slope Guy, that actually means that this is a horizontal line. This line has the same y value for every point on it. Let's do one more example. Let's find the slope between -3, 2 and -3, -7. So this time, what can I do to get from -3 to -3? I could add 0. To get from 2 to -7, I need to subtract 9. So the slope here is -9 divided by 0. Now, a number that's not 0 divided by 0 is not 0. It's just undefined. There's no value for 9 divided by 0, so it's undefined. This is actually a vertical line. This is a line that goes straight up and down. And I can see that because the x's are the same. Thanks for watching.